we're going to get some graphs of these functions. We're going to get it by taking steps toward getting like maximum info about them. So we're going to have the amplitude, the period, the phase shift, and the midline. And by the time we get those things, it's going to be like a piece of cake to actually get the graph. We will start, as always, with number 1. The amplitude of this is the number in front of the sine, not the number on the inside. So the amplitude is 1. When there's no number in front of it, then it's implied that the number there is 1. So the amplitude is 1. And let's see, the period. Well, for this, there's 2 ways to look at it. You can look at it as either the period is 2 pi over b, where the b is the number that is multiplied by the x, or you can also look at it as a dilation applied to this. So both of those get the same answer, but to have a formula, 2 pi divided by 1/2 will end up being 4 pi for the period. If you want, you can look at it as the dilation, meaning that it's a horizontal stretch. This is a horizontal stretch because you're multiplying x by 1/2. It's by a factor of 2, and the usual period of 2 pi gets turned into 4 pi. The phase shift, remember that if this is like a difference between the second and third, the first and second problem, if you've got something here that needs to be factored, then you need to factor that before you state the phase shift, because it's just too messy to try to do it otherwise. But in this case, it's already factored, and the phase shift is already written right in front of you. So this phase shift is going to be pi over 4. And because it's plus, it's to the left. The only thing left to do is the midline. And the midline is if there's a plus or a minus at the end of it. This has a midline of y equals 0 because there is no plus at the end of it. There's no minus at the end of it. Nice and easy. With these things in mind, it's possible to draw a graph really, really easily. Usually you want to draw a graph that's like in positive territory. That's the easiest way to think of it. I'm going to do, I'll mark 1 period worth. So let's do from 0 to 4 pi. That's 4 pi, meaning halfway would be 2 pi. A quarter of the way is pi, and 3/4 of the way is 3 pi. Amplitude of 1 means that I can make the top of this 1 and the bottom -1. That'll be the highest and lowest that it goes. The phase shift is pi over 4 to the left. So this, honestly, this is going to be a little bit hard to show because like usually we would think of this as being, you'd have stopovers at like, you know, the pi, the 2 pi, the 3 pi, and the 4 pi. But really, this is going to do all the interesting stuff at just very slightly decreased versions of all of those things, which is going to be a little bit irritating. So to help us out with that, what I'm going to do is put little markers here at like 3/4 of the way to pi. Okay. And then 3/4 of the way to 2 pi, 3/4 of the way to 3 pi, 3/4 of the way to 4 pi. So really this is 3 pi over 4. 2 pi minus pi over 4 would be 7 pi over 4. 3 pi minus pi over 4 is 11 pi over 4. And for the same reason, this is 15 pi over 4. The reason I'm marking these is that that's where the interesting stuff is going to happen. And over here, because I was going to graph 0 as the first point, now I'll graph negative pi over 4. So this is going to go there, and then it goes up to a maximum at the first one because this is sine behavior. It begins at the midline, goes up to the maximum, down to the midline again, then down to the minimum, and then up to the midline. And the graph is like this. Easy, right? Even with the phase shift, it becomes easy as long as you offset things just by a little bit. Let's do the second one. The second one has an amplitude of 2, a period of Normally it's 2 pi. So this has been stretched by a factor of 3/2. This one honestly is kind of weird. So I'm going to say we'll do the 2 pi over b thing for this. 2 pi times 3/2. Oh, would you look at that? It's 3 pi. So not that bad. The phase shift, in order to do this, I'm going to factor first. So this is going to turn to 2 sine of 2/3 times sine times x minus, and then I need to factor a 2/3 out of pi over 6. Well, 2/3 times what equals 1/6? I know that this has to be, it has to end with a sixth. So 2/3 times, I think that would be, one over, and then 2 to cancel with this, and then another 2 to turn that into a 6. I promise I can math. That would be 1/4. And of course, there's a pi in there. So this is the factored version. This allows us to state the phase change. It's the phase shift is pi over 4, and that's to the right because it's minus. The midline is y equals 0 because there's no plus or minus. We mark one period of 3 pi. And then halfway to that is 3 pi over 2. Halfway to that is 3 pi over 4. And halfway between these, that would be, let's see, 3 pi over 2 plus 3 pi over 4 is 9 pi over 4. Maximum of 2, minimum of -2. And now this has a phase shift of pi over 4 to the right. So this is sine. That means that yes, it will start at the origin, but it's going to be offset by pi over 4. So I'm going to draw this pi over 4, and then I'll offset all of these by pi over 4 as well. So this will be actually just pi. This, what's 3 pi over 2 plus pi over 4? That would be 7 pi over 4. 6 pi over 4 plus 7 plus pi over 4 is 7 pi over 4. And then this plus pi over 4 would be 10 pi over 4, or 5 pi over 2. 3 pi plus pi over 4 would be 13 pi over 4. This is like the fraction reduction Olympics right here. So we're going to begin at our new origin. The origin has been moved by pi over 4 to the right. And then we proceed with a normal sine type pattern. It goes up to the top at pi, then down to the midline at 7 pi over 4, down to the minimum at 5 pi over 2, and up to the midline again. Things connect the usual way. Okay, cool. That's it. I'm sorry that we didn't do a cosine graph, but really that follows the same sort of rules, and I think that wouldn't be too hard to do.